Good afternoon, my name is Santiago Flores. This presentation is for the subject Fluid Mechanics. That would be Professor Hector Dusan, and I will talk about Bernoulli theorem and Torricelli theorem. Bernoulli's principle or theorem introduction is a fundamental law of fluid dynamics that establishes the relationship between pressure, velocity, and height of a moving fluid. This principle has important application in various fields, from aeronautics to medicine. Explanation of Bernoulli's theorem: pressure and velocity. As the speed of a fluid increases, the pressure decreases, and vice versa. Kinetic and potential energy. The sum of pressure, kinetic energy, and potential energy of the fluid remains constant along its trajectory. A practical application: this principle is used in aircraft with design, the operation of carburetors, and the analysis of blood flow. Application of Bernoulli's theorem: aeronautics. Bernoulli's theorem explains how lift is generated on airplane wings. Medicine is used to understand blood flow and the function of the heart. Hydraulic is all the efficient design of pipette system and pumps. The influence of Bernoulli's theorem. Outlet velocity. Bernoulli's theorem allows for the calculation of the outlet velocity of a fluid door orifice. Leaf height is this also used to determine the height to which a fluid can be lifted in a pipette system. Pump design. The Bernoulli principle is fundamental for the efficient design of hydraulic pumps and turrets. Relationship with Torricelli theorem. Bernoulli's theorem describes the relationship between the pressure, velocity, and height of a fluid. Torricelli's theorem explains the exit velocity of a fluid down an orifice. Connection. Torricelli's theorem is based on Bernoulli's principle to determine the exit velocity. The influence of Bernoulli's theorem on Torricelli's theorem. The Bernoulli's theorem established the fundamental relationship between the pressure, velocity, and height of a moving fluid. This fundamental principle is closely related to the Torricelli's theorem, which explains the exit velocity of a fluid through an orifice. The connection between these two theorems is that Torricelli theorem is based on Bernoulli's principle to determine the exit velocity of the fluid. Specifically, Torricelli used Bernoulli's principle to derive the formula that calculates the efflux velocity of a liquid through an orifice in a reservoir. To explain this part, we will relate the imagined initiality shown with Bernoulli's theorem in the upper part, slowing down the pressure cancel since pressure 1 and 2 are same and velocity 1 cancel since the initial velocity is 0. C1 is equal to speed 2 over this the gravity plus 2 gravity plus C2 C1 and C2 are height. The equality will be speed 2 at the root of 2 times the height times h is height, C1 más a plus C2 is h. This being a equality of Torricelli theorem to find the speed. Practical example of Torricelli's theorem. Torricelli's theorem is based of Bernoulli principle to determine exit velocity of down an orifice. This theorem has various applications in everyday life. In the design of pipe system, Torricelli's theorem is used to calculate the fluid velocity and pressure at different points in the system, which allow for optimizing the design and operation of the pipes. In the field of hydraulic, Torricelli theorem is applied to the design of sprinkler irrigation system. The exit velocity of the water through the orifice of the sprinklers is calculated using this principle. Furthermore, in medicine, Torricelli's theorem is exploited to understand blood circulation on the human body, as human body has blood flow through blood vessels that can be considered as orifices through which the flow occurs. In this part is explication of the project. For this final project related to fluid mechanical and Torricelli's principle, as soon as we have the material and equipment ready, we carried out the following step, where we have the following. Initially, we make the project assembly diagram, make a hole the bottom to place the gravity water outlet towards the pump, position the water pump after the gallon level below the gallon to ensure enough water reach the pump. 3. After position the water pump assembly to open the holes in the tube, which should be responsible for drip irrigation. 4. Place the return tube towards the pump filling gallon to have circle and not accumulate pressure in the tube and thrush about. Finally, we tested the project by checking Torricelli's principle in a drip irrigation system. Thank you.